Hi everyone, my name is Gursharanbir Singh. Today I'm going to present my presentation about normalization in data. So first of all, I would like to describe what is normalization. Basically, we perform normalization to rearrange data in order to eliminate redundancy. Moreover, we check if there is any illogical data dependencies. In order to remove these dependencies, we create more tables to adjust data logically. So there are different forms of normalization which I have described further in my next slides. So first of all, I would like to describe my dependency diagram. So student name is the primary key in the given table and students details depend upon the primary key. So there is functional dependency between the key attribute and the attribute which are student details, like student date of birth, student home country, student subject, and other ones mentioned in the blue colored arrows. Here they are. And subject is determined by the subject code, and subject lecturer is determined by the subject, which are non-attribute keys. So the dependency is called transitive dependency. So basically the given table is not in normal form, and I need to normalize it in the first, second, and third this normal form respectively. Each of them is described in my next slides. So here in order to do it first, normal form, each value is in the attribute should be atomic. No multi-valued attribute are allowed. Every attribute should be have a unique name. So for example, in insertion anomaly, we cannot add to database because other data is missing. For example, in the given table, if we introduce a new course to existing students doesn't want to take, then the course we need a new students for this course. So the existing students can't take the new course if they don't want to take it. So as if we don't have a new student, so we can't add a new course to the table. In update anomaly exists when one or more instance of duplicate data is updated. For example, in the given table, if user wants to update the credit points of any course, then it will run to the query of the table and all students that are registered in the course individually, which are not a good approach. A deletion anomaly occurs when you delete a record from the table and the attribute are depend on that, and they all got deleted. For example, in the given table, the student name is the primary key. So if you want to delete the student record, it will delete all the course details and school details as well. So as there were multiple values of student phone number, student subjects, name of lecturers, student subject course, so to convert it in the first normal form, I added new attributes in the table as student phone number 1, student phone number 2, and likewise other attributes of lecturer name, subjects, and their course were normalized. Similarly, in this slide, I also create a new attribute to the subject credit point, subject marks, and subject grades, that is subject credit point 1, subject credit point 2, subject credit point 3 respectively for the student subject mark and student's grade. So as the given table, student name is the primary key, and there are many attributes in the table which are not depend on the student name. Therefore, to normalize it in the necessary to make additional tables to order to separate the dependent attributes. 2 more tables are created in next slides. In this slide, we separated the attributes are starting from subject because it is the need of second normal form that all the non-key attributes should be depend on key attribute in a table. So in the given table, these 3 attributes were not depending upon the student, which is the primary key of our table. Hence in the tables to subject code is the primary key. Now all the non-key attributes are depend on the key attribute in this table, and all the student attributes will remain in the original for table for now. They don't need to be shifted. In this slide, we made another table of school and assigned it an ID as school had or school name or school phone is not dependent on student name, which is primary key in the given table. So we created this one where school information is dependent on school ID. Now the non-key attributes are depending upon non-attribute school ID. As it is mentioned in the given task that we have to add additional table in order to normalization in the third form, normal form. So we added 6 new tables in the next slides, which I will show you. So it is necessary to remove student home country and student continent from the original given student table, because we have to remove transitive dependencies. We have already separated subjects and school attributes and in second NF. Now to remove these attributes, I have set the student home country and student ID as a foreign key, and it won't affect any related to students in the table or deletion of updating also to finish transitive dependencies. In the home country table, I have assigned IDs to the countries and made it as a primary key of the table, and continent ID as foreign key. Similarly, in the second table, I have assigned IDs as continents and made its primary key for the table. In the student subject table, I have set a student name as a primary key and subject code as a foreign key. That any data released to subject has deleted, then it must be deleted all the student data present in that table. Similarly, in this subject table, I have set a subject code as primary key because there is nothing related to student in this table. Only subject information will be deleted or updated in future. In school table, I have assigned IDs and make it as a primary key for the table, as a school information was transitively dependent on student name. To avoid future inconvenience, we made another table for school information. Now I would like to explain my entity relationship diagram for this normalization of data. So this is the entity relationship data of given table after normalization it into the third normal form. Different symbols and connectors are used to represent the entities and relationship among the respectively. Mainly the rounded rectangles are used to denote the entities, and the connectors with arrows or lines are used to denote the relations between entities depending upon the relationship types. Entities rounded rectangle boxes contains the primary, foreign and non-attribute inside them. Therefore, I have assigned each table a unique name, and inside each box all the key and non-key attributes are written for that table. The table name and the key attributes written in the bold format of each of the table and non-key attribute are written in the normal format. So at last, as we use database for ease, therefore the unnormalized data lead to data anomalies, which is in turn to optimal approach to use. Moreover, in order to make it more normalized or more stable, data normalization is one of the most important thing to know in database fundamentals. So it makes data more stable and more easy to access. So here I provide reference for clarification of my work. That's all from me. Thank you very much. Thanks for listening.